But yes, I'd like to talk to you today about our new transport protocol that is applicable both for remote contribution, but also for production, which sends RTP sessions over quick transport. I realize this is a little bit different to the other presentations we've had on today. But yeah, there's some work that we've been doing. So if we can go to the next slide, please, Richard. We, the BBC, have been spending some time looking at how we, as the BBC, do contribution over the internet. Historically, we've used RTMPS to do contribution, but we have also performed some research more recently into SRT and RIST. But when we were looking to understand the RIST main profile in particular, we had the idea to wrap RTP in quick transport instead of the GRE and UDP solution that RIST uses to do multiplexing. For those who aren't familiar with it, here's a quick introduction to Quick. Quick was imagined as a TCP replacement by Google back in 2012. And Quick is standardized by the IETF as RFC 9000. And it is a secure, reliable multiplex transport protocol built on top of UDP. So this is a connection-oriented protocol that supports TLS 1.3 encryption, selective acknowledgements, and a fast connection handshake, as well as being able to move an extant connection to a new network path without needing to reset. And this is the connection migration. There is also active work in the IETF to extend Quick to support multipath in the future. One of the primary reasons we wanted to look at Quick was because it underpins the next generation of HTTP, and as such means that it should be much easier to pass through firewalls than some of the existing solutions, because it uses conventional UDP packets as well as a conventional client-server connection model. Quick also has an unreliable datagram extension, which we can use to send protocols like RTP through a Quick connection. And while the Quick level loss recovery is disabled for the datagram frame, we can simply reuse conventional RTCP retransmission techniques. And we'll be able to multiplex RTP media over the same connection with HTTP3, which we could probably use in the future to build rich web applications for contribution. So contributors only need a conventional web browser and not a specific set of applications to contribute to any a news gathering event or something like that. Next slide, please, Richard. We call our solution QRT, or Quick RTP Tunneling. It's built entirely on tried and tested open standards, and it allows us to multiplex multiple RTP sessions across one quick connection. So this could have your primary contribution video and audio on one session, your field monitor return video on another, and then another session for talkback to the crew. Using RTP, we can support every codec and packaging format that there's already an RTP mapping for, all the way from MPEG-1 up to the right to VVC. We also use RTCP retransmission, as I've already said, which conventionally is the RTP retransmission payload format specified in 4588, or we could optionally incorporate the RIST range-based retransmission mechanism. There's also both quick congestion control for overall connection management, as well as the ability to use RTCP congestion control schemes such as Scream or NADA. As the solution doesn't really change any of the RTP packets themselves, then QRT could also be used to transport as a transparent tunnel to transport RTP that could be fed straight into your SMPTE ST2110 production network, or it could be an end-to-end solution that is then converted at the production end. Next slide, please, Richard. So one of the features that Quick specifically affords us is the connection migration feature. So Quick connections are not bounded by the traditional 5-tuple idea of a connection, but instead by ephemeral connection identifiers. This allows a device to transition between networks seamlessly without needing to reset the connection that's currently in use. For example, this means that in the event of a loss of service on one network path, the device could seamlessly switch to another. Quick also allows us to probe these network connection paths in preparation for a migration event, so this can be done in such a way to minimize the latency of such a change, which is obviously quite important when you're doing something in live. In the future, the aforementioned multipath extension will also allow us to further use both paths, or even more paths than two, simultaneously if required for either link bonding or for increased throughput, or for higher resilience by sending the same packets down all paths. This could be, for example, using the current way of having multiple SIM cards on different mobile networks. Next slide, please, Richard. So this is just a quick comparison of the various features and where they come from. So obviously the media codec and packaging support is defined by RTP. The Quick multipath extension that I mentioned earlier is about to be adopted by the Quick working group, so this is noted as a future feature. But we can already perform connection migration as it currently stands. The multiplexing comes from QRT, while Quick supplies the TLS, congestion control and loss detection, used in the solution. We can then augment the Quick congestion control with RTP congestion control and include application level retransmission, or FEC, from RTP. Next slides, please, Richard. So the current status of the work is that there's already a QRT draft specification published. I have been working on a prototype implementation and using that to perform experience so that I can provide guidance on the usage of quick and RTP congestion control mechanisms so that the two aren't fighting against one another. Also in the future, we're looking at developing a means for carrying SIP messages over quick to do inbound call handling, integrating the future quick multipath features, as well as some way of adding prioritization to RTP streams being sent across a QRT connection, so that you can opt to degrade your return video to save bandwidth over sacrificing your main contribution feed, for example. And as an extension to the multiplexing of HTTP3 and QRT streams, as I mentioned earlier, we're also looking at the convergence of WebRTC or the future web transport with our work. So that was a quick blast through, but thank you very much for listening. And if you've got any questions, I'm more than happy to answer them.